Hey everyone, welcome back to another LeetCode problem solving video. Today we are tackling LeetCode 394 Decode String. The problem gives us an encoded string where number before square brackets means that whatever is inside those brackets must be repeated exactly that many times. For instance, 3 bracket A, 2 bracket BC turns into triple A, BC, BC. Now this looks easy on the surface, but it gets tricky when brackets are deeply nested inside each other, like 3 bracket A inside that bracket 2 and again in bracket C. Today we are going to look at an incredibly elegant recursive approach in C++ that treats every single open bracket as a fresh sub-problem, allowing us to peel back layers naturally. Let's look at the strategy first and then we will jump straight into the code. So before diving into the syntax, let's understand the recursive strategy to handle nested brackets seamlessly. Because nested structures repeat the exact same rules at deeper levels, we can think of each set of brackets as an independent task. We will scan the string from left to right using a global pointer index I passed by reference across all function calls. This ensures that when a deeper level moves the pointer forward, the parent level knows exactly where to pick back up. If we counter regular letters, we just collect them into our current result level. If we hit a number, we parse the full multiplier and get red. The moment we see the opening bracket, we hit pause on our current level and launch a recursive call to handle the inner sub-problem. That recursive call will run independently until it hits a closing bracket. It then returns its fully decoded inner string back to us. We multiply it, append it to our local result, and continue our scan. Now that the blueprint is clear, let's see how this translates into C++ code block by block. So to start, let's look at our main calling function decode string. We initialize our tracking pointer index I to 0 and instantly kick off our helper function decode, passing our index by reference so every layer shares the same position tracker. So let's do that. So int I equals to 0 and return decode s comma I. Okay. Oh, sorry. We haven't made the function. First of all, let's make the function string decode string string s int I equals to 0 mm, return decode s comma I. Now let's examine our recursive helper function decode. We declare an empty local string resultant to accumulate the decoded text for the current bracket level. Right after we set up while loop that runs as long as our pointer I is within string bounds and does not point to a closing bracket. A closing bracket indicates that the specific subproblem level is finished. So now let's do that. Okay. Okay. So now here string res equals to empty, and while I less than s dot size and s of I not equals to the closing square bracket. Okay, sorry here. So now inside the loop we check our conditions. Condition 1. If the current character is alphabetical letter, it doesn't need scaling yet. We simply append it to our local resultant string and advance our pointer index by 1. So let's do that. If is alpha s of I, then resultant plus equals to s of I and I plus plus. Now condition 2. If the current character is a digit, we have a multiplier block. We initialize unknown to 0 and use a nested while loop to parse out multi-digit numbers like 1, 2. We mathematically shift the digits and increment I until we run out of numbers. So, else if is digit s of I, then int num equals to 0 while I less than s dot size and is digit s of I. Okay, then num equals to num into 10 plus s of I minus 0 and then again I plus plus. So the moment the passing loop stops, I is pointing at the opening bracket. We execute I plus plus to skip past it. Now we hit the brilliant part. We trigger a recursive call decode s comma I to process everything inside this new bracket layer, storing its fully decoded output inside a temporary string temp. When that child function returns, I will be resting on the corresponding closing bracket, which we skip using another I plus plus. So after that, I plus plus, okay, and then string temp equals to decode s comma I, then again I plus. Now that we have the inner string stored safely in temp, we use a simple while loop that decrements our past multiplier num, appending temp to our main resultant string each time. Once the outer while loop either finishes the string or hits a closing bracket, we exit the loop and return our accumulated resultant string back to the parent level. So after that, while num, okay, resultant plus equals to temp and num minus minus, and then we will just simply return res. Okay, so this is our code. I think let's run and check. I think there is some error. Yes, no, not this. Something answer will be wrong. Is alpha s of I. Oh, here, spelling. Please wait a minute. Let me check what, as I think that let's remember that check. Okay, function definition is not allowed here. I think so. This is the opening of while this closing. Okay, so the problem is here as we are creating a function inside the function. Okay, now let's first of all beautify this code. Okay, now let's submit it. Okay, that's working properly. Now let's submit it as we have just ran the code. Okay, it's perfectly working. Now let's move towards the driver. Okay, so now let now let the our example be 2, then bracket A, then on inside that square bracket 3 and B. Okay, means nested brackets are there. Now the level 1. So I equals to 0 as of 0 is 2, a digit. We parse it, num equals to 2. I advances to 1. We skip it, I becomes 2. We hit the recursive call string temp equals to decode as of I. Level 1 pauses, level 2 is launch. Now res equals to empty. I is currently 2, as of 2 is a, an alphabet character. We append it, result res equals to a, I increments to 3. Now as of 3 is 3, a digit. We parse it, num equals to 3. I advance to 4, the inner close opening bracket. We skip it, I becomes 5. We hit the recursive call string temp equals to decode s comma I. Level 2 pauses, level res equals to again empty. I is currently 5. S of 5 is B, an alphabet character. We append it. Resultant equals to B. I increments to 6. Now S of 6 is closing bracket. The loop condition S of I not equals to closing fails. Level 3 returns res B back to level 2 and terminates. Now level 2 resumes. Its temp receives B. we skip the bracket I was resting on. I becomes 7. We multiply temp B by its num, which is 3, and add it to level 2 res means A. Level 2's res becomes A and triple time B. I is now 7 and S of 7 is the outer closing square bracket. Level 2's loop breakdowns and return A and triple B to level 1. Now back to the level 1. Level 1 resumes its temp receives A and triple B. We skip the last bracket. I becomes 8. We multiply temp A triple times B by num, which is 2, and add it to level 1's res, which is empty. Now level 1's res become A BB, and again A triple times B and A triple times B. The string ends. The loop finishes, and our absolute final answer is return. And now the try run finishes. Now let's discuss about the complexities. So the time complexity. So every character in the encoded string is read exactly once by our pointer index I. However, we construct and copy strings multiple times when inflating the multipliers. Thus, the time complexity is bounded by the order of length of the output string, which is optimal because you must spend time building the final output. Space complexity. The maximum number of active frames on our recursive call stack matches the deepest level of bracket nesting in the input string. In addition, we allocate memory for string building. Therefore, the space complexity is also linear order of length of the output string to account for the call, stack, and character copies. And that is how you solve the you solve the decode string problem using clean reference pointer recursion, handling subproblems by pausing and breaking them down layer by layer, mix, handling deeply nested expression incredibly intuitive. And if this block by block breakdown and visual try run help the logic click for you, make sure to slam that like button, subscribe to the channel for more clean code walkthroughs, and let me know if you have any kind of doubt in this solution in the comment section below. Keep grinding those problems, and I will see you in the next video.